let's start talking through these three, and then we'll get to our story problems. For the first one, part A, I want to solve this for which variable? I want to solve it for I. So I need to get the I all alone. Where is I currently? Yeah, it's in the denominator of the fraction over on the right-hand side. How can I get it out of a denominator? Multiply. So I'm going to multiply this one by I. Do it to one side. Got to do it to the other. So my i's cancel. And I have IR equals V. One more step and I've got it alone. Divide by R. And so I get I equals V over R. Absolutely. We're working with literal equations. So, we had a bit of an explanation about what this first one means. Does anybody know what the second formula is for? What B is for? Close. Cylinder. Not a full cylinder. Let's keep going. Why is it, like, where's that 1/3 coming from? Because the pi r squared, that's circle, right? That's like the base of our shape. H is the height of our shape, so if it didn't have that 1/3, then it's a cylinder.
It's a cone?
It's a cone.
I just jumped to this.
This is a cone. It is a cylinder that only has 1/3 of itself left. All right, I want to solve this for H. Divide by, I'm sorry, by what? Divide by H. If I divide by H, it's going to put it in the denominator, which is going to be hard to get it out again. Anthony?
Divide both sides by 1/3 pi r squared.
Divide by 1/3 pi r squared. I like it, except I hate dividing by fractions. I can't times it by 3 pi r squared. Yes. Is that what you were going to say, Ezekiel? I'm going to multiply by 3 first, because then I can not deal with a fraction. And then from here, I can divide the pi and the r squared simultaneously, since I'm using the same operation to get rid of both of them. And so I end up with H, where the height of our cone is equal to 3 times the volume divided by pi r squared. I love it when you guys recognize what these particular formulas are for. Last one, part C. I want to solve this for Q.
I don't know that equation.
I don't either. I'm convinced that this last one was literally just made up to give us some practice. Where is Q? It's in the denominator. In how many spots? 2 spots. If I'm going to solve for it, if I'm going to get it alone, I need to isolate it. I need it all combined together, right? So I'm going to have to find some way of doing that. First thing I would do, I'd like to... He's killing kittens.
I just had to do math in my first period. I am not awake.
Valid. No. The reason I can't cancel, look, if this wasn't here, then absolutely I could cancel. If that first part wasn't there, because here, if I leave that part off, like if it didn't exist, then P is a factor of my entire denominator.
Wait, so if we get rid of it by a negative q in the denominator.
By a negative in my denominator.
Negative q, like if you like
What?
whatever.
But multiplication won't cancel addition or subtraction.
My brain is.
Yeah. No, it's fine. I love having these conversations because when you guys are sitting down and doing your work on your own or with the buddy, these are the kinds of places that our mind goes. So I like to have these conversations in class. I'm looking at this.
Distribute.
I like distributing. Is that the only first place to start? No.
That's not-
But it is a valid first place to start if my goal is to get the Q all by itself. There's nothing wrong with that. So P, and then on the bottom I have Q plus P minus PQ. I still have Q in 2 spots, but now at least I don't have those parentheses. And Q is still in my denominator. How have we dealt with getting things out of denominators already? Multiplication. I have to multiply by everything that's in that denominator. I need to treat this as a whole factor here. So I'm going to multiply by Q plus P minus PQ on both sides. I am not going to distribute that on the left.
Divide by that.
Mhm. I'm going to divide by S so that I can get rid of that piece. And now I finally have the ability to do stuff with addition and subtraction for anything I want to get rid of, because now we're not multiplying stuff anymore. So I have Q plus P minus PQ equals P over S. Which piece do I really wish was not on the left-hand side? P. I want just the things with Q's on the left-hand side. So I'm going to subtract P from both sides. This is going to get a little bit messy. I'm going to have to swing my work around. All right. So I've got Q minus PQ equals P over S minus P. I could give that a common denominator and combine those things together, but I don't need to. They didn't ask me to do all of that. They asked me to solve for Q. So that is my big focus and goal right now. I still have Q in 2 spots. It's right here and right here. How can I get just one Q? I can. Yes, sir.
Could you add PQ on both sides and then divide by Q on both sides?
The third derivative piece.
What if you ask politely?
Asking politely to get Q all by itself. This is in both of my terms over here, right?
I guess you just take Q out of both of them and put it.
What are you using when you say take Q out of both of them? Division. We're going to use factoring. We're going to factor it out. This is a GCF. Q is a GCF of both of those pieces.
Oh, I get it. Yeah.
Yep.
Yeah.
So I'm going to factor a Q out here. Bring it around here because I ran out of room.
And that would be like 1
So I have Q, yes. We would have 1 minus P right here is equal to P over S minus P.
And then you would like divide.
Then we would divide.
That's ugly.
It is ugly. 1 over P, or sorry, not 1 over P, 1 minus P. And so I get Q is equal to this horrendous looking fraction. I have P minus S, or sorry, P over S minus P over 1 minus P.
You don't want us to simplify that?
I'm okay if you leave it like that. Could you simplify it further? Yeah, we could. If you simplified it further, you could end up with P minus SP over S times 1 minus P. But I'm okay if you leave it like that. All right. If you want to switch and do your work on the worksheet now that has all the story problems written on it, that is totally fine. If you find that you don't have enough room, bleed over into your notebook, I guess, or write small. So I want to try to figure out, this student really wants to get an 80 in the class.
Dang, that sucks.
We've got their test scores, 75, 82, 71, 84. We want to know what their next test score would need to be in order to bring their average. You okay? How would you approach this problem? Add them all up and divide. Divide by what? Is it 4 or is it 5, and why? We want to find out what the next score is. Does knowing what the current average is help me figure that out?
Probably.
Possibly.
Because then you can figure out how much, like, if it needs
I guess
to
you
be
could
bigger or
estimate
lower
at
than
that point.
80.
We don't
want
wanna
to
estimate.
5, then you know how much you're missing to get up to that.
There's a couple different ways that I've been able to think through solving this problem.
Because if you just put in the fifth score as an X, then you can.
I like that. So one of the things that I'm glad Matthew just brought up, we need to define what our variables are. If you're going to use a variable to solve, you got to tell me what that variable means. So he said we're going to let X be the 5th test score, which we don't know what it is yet. So we can take the scores that we do know, 75, 82, 71, 84, plus X, divide that by 5, and we want the average of that to come out to be what? 80. Well, I can sum all of these. I can also get rid of that denominator at the same time. How do I get rid of that denominator? Multiply both sides by 5. What do I get when I sum 75, 82, 71, and 84? 312. So 312 plus X equals 400. So X would be what? 88. When we're talking about a story problem, that would not be a sufficient answer on a quiz or a test. You need to actually answer the question. What was the question that was asked? What score on the next test? So I need a sentence. It doesn't have to be long, it doesn't have to be complicated, but the next test needs to be an 88, or they need 88 on the next test. I can think of another way of approaching this problem that would still get us to a correct final answer. All right. You could use guess and check. What weight does the missing test have? What percent of their overall grade is that missing test that we don't know the score for? 1/5, right? So I could look at this. If I did find the average, it would have to be out of 5, not out of 4, because we're going to be averaging 5 tests. But I could sum up the 75, 82, 71, 84 over 5. That is 4 of the 5 tests. So this is like 4/5 of the grade. Plus 1/5 for the test that I don't know. And that would equal 80. I'm not actually doing anything different. I'm just kind of separating out that fraction. And I'm getting a fractional amount that I have the value for, and then I have a fraction that has my x in it. So I'd have, what, 312 over 5. What is 312 over 5?
I don't know, not pretty.
Grab a calculator for me real quick. I know it's a no calculator course, but grab a calculator.
62.4.
62.4 plus 1/5 x is equal to 80. I can subtract 62.4 from both sides. What is 80 minus 62.4? 17.6. And then I can multiply both sides by 5.
Yeah, no way.
And I get what?
88.
88. Double check it on your calculator for me. Yep, 17.6 times 5.
Yeah, it's 88.
It is 88. Wonderful. Did I actually do anything fundamentally different in these two different ways of approaching it? No. I even know of another way we could approach this one. First period, somebody said, I don't want X to mean that missing test score that I don't know yet. Let's let X mean the sum of all the tests. Whatever you have your variable meaning, though, you have to tell me what that means. Let's look at the next one. A worker's take-home pay is $492 after deductions totaling 40% of the gross pay have been subtracted. What was the gross pay? What is gross pay?
That's a good question.
Gross is like the biggest. It's not a number. It's a gross figure. Or is it not?
There is a value, like there's a measurement that is like considered like a gross. It's kind of like a ton. That is, I don't know if it's spelled the same way or not. But no, I love that you guys, like, please don't feel embarrassed when you bring up stuff like that and it ends up not exactly applying. That's not a problem.
But isn't the gross like the highest?
Mm-hmm. So the gross pay, I think about this almost like, it's like a raw score. It's your raw pay. It's if you showed up and they were going to pay you in cash for what you did. Just like you're getting paid $10 an hour, you've been here for 5 hours, here's $50. They don't deduct taxes, they don't deduct for any benefits you might have opted for, they're not taking out retirement, they're not taking anything out. You get it all. That's what our gross pay is. So the raw pay before deductions. We know what their check was. How much was their check for? $492, but they've had money taken out of it. How much money was taken out?
40%.
40% of what?
X.
Yes. Where X means what?
Gross pay.
We're going to let X mean gross pay. So I heard 0.4x. 0.4x, what does that mean if I do that?
Alright, I'll allow 40%.
That is 40% of what?
X.
What is X?
Gross pay.
Gross pay. So 40% of gross pay. What has happened to that 40% of the gross pay? What did it say happened with that? It was subtracted from what?
The pay
From the gross pay, right?
from Y.
From Y?
Yes,
No,
because we don't know how much the original was.
0.4 x.
You're right, but you defined it already.
X minus
The original amount was my gross pay.
Come here.
From that raw amount,
Come here.
they're going to deduct or remove 40% of it.
X minus 0.4 x.
And how much is left over?
492.
Yes, yes, sir.
So could you just multiply 490, or divide 492 divided by 0.6?
Yes. We're going to do x minus 0.4x equals 492. Let's talk about where those numbers came from.
Don't play with me right
Oh, okay. This makes
Oh, I
much
was
more
right.
sense.
These two right here, so x is my gross pay. So what I'm saying with this equation is gross pay minus 40% of the gross pay. Is that what they described up above in the words?
And the 0.6 is the 492. I get it. Because you have to add it up to 1.
There we go. I'm hearing it. X and 0.4x. Are those two things like terms? Yes. Same variable with the same exponent. Those are like terms. So I can combine these together. I can subtract their coefficients. I see the coefficient in front of the 1. It's 0.4. What's the coefficient in front of the first x? A 1. So I have 1x minus 0.4x. And I get 0.6x. Or another way to think about this, if you start with all your money, 100%, and they take away 40%, how much are you left with? 60%. That's what this says right here. You have 60% of your gross pay remaining, and that was the $492. They took 40% for taxes and deductions, so you have 60% left over. Divide by 0.6.
So, are we going to get questions like this on a test?
It is definitely possible. Talk to me about how you would do something like this without a calculator.
I wouldn't.
Not a good answer.
You can't.
I suffer with my half a point.
All right. Tell me another way to write division other than a fraction.
Divide.
Yeah. Let's write some long division style. 0.6 divided by 492. How do I do that? Does anybody remember?
No.
Yes. I can move this decimal point over, but if I do that one,
0.
yep. I move this one over.
Wait, like being so for real, we're dividing that out on tests?
You might.
Yeah. Yeah, we are, Jaden.
If we use decimals, why don't they give us calculators?
It's a no calculator course.
This should.
Now, that being said, do you think I'm going to give you every single problem where you have to divide by decimals? No. You won't have enough time.
If you do, we're leaving.
I will miss you. I will miss you. How many times does 6 go into 49?
7.
7 times. 7 times 6 is what?
42.
42. So I'm going to subtract that. I get 7, and then I have to drop the 2 and the 0. How many times does 6 go into 72?
12 times.
Ooh, then that means I could have taken out another one, right?
Huh?
An 8. 6 times 8 is 48.
Oh, yeah.
Yeah.
Come on.
Because if you look at this right here, is that bigger than what I was dividing by?
Shame on you. Listen, did you?
All right.
648.
Listen. 820.
All right, so I have 48. I can bring this down. How many times does 6 go into 120? 20 times. So x is 820, which means my answer to this question is what?
8
There we go. Give me a sentence. The gross pay was $820. All right. When you guys go to do this homework, the sentence is for the most part pre-typed. All you need to do is enter your value when it comes to the Canvas homework. When you take a quiz for me, when you take a test, story problems, I want your final answer to actually answer the question. Okay? So you need to give me back some words along with your numerical answer. Do we have any questions so far? Cool. Let's look at number 3. A person's intelligence quotient, IQ, is determined by multiplying the quotient of his or her mental age and chronological age by 100. What?
Why? What?
Let's break apart the second part of that sentence and figure out what they're actually describing. What do they tell me we're doing? Dividing. Tell me what word meant dividing. Quotient. When we are dividing, or I have a fraction, it's really important that I know which piece is the numerator and which piece is the denominator, because if I switch those around, that's really going to affect my answer. So the quotient of what?
Their mental age.
Mental age. Would that be the numerator or the denominator?
The denominator. The numerator.
They told me I'm going to have a quotient of. If they say you have a quotient of, the very next thing they're telling you is what goes on top. And then the next thing they tell you is what goes on the bottom. So the mental age is going to be my numerator. And what's my denominator?
The 100.
Chronological age. This is my denominator.
What's chronological?
Chronological age is like how old are you on your next birthday versus your mental age, which would be compared to other people's scores and knowing what their ages are, where do you fit for the average 15-year-old, the average 18, like which of these buckets do you fit in based on your test scores, not how many years you've been alive.
3-year-old.
All right. So I know that the mental age is the numerator. I'm going to go ahead and write this down right here. Mental age divided by the chronological age. And I am not spelling that whole word out. Times 100. Yes. It tells us here that we are going to multiply this thing by 100. So I'm going to take this fraction and multiply it by 100, and that's how I find the IQ. So how would I answer part A? I want to find the IQ of a 12-year-old child whose mental age is 15. 15 divided by 12 times 100 is equal to the IQ. And I'm okay if you don't define IQ at that point because it defined it for us up above. If you use a variable here, you got to tell me what your variable means. 15 divided by 12. Does that go in at least one whole time?
Mm-hmm.
So this would be 1 and what?
1/4.
1 and 1/4 times 100. 1/4 is the same as what fraction? 0.25. So I have 1.25 times 100 is equal to the IQ of this child. And so their IQ is what? 125 is equal to the IQ.
How do you know your mental age?
Mental age, a lot of times they'll do that through like an actual IQ test. If you took any of the tests to potentially be considered for high ability in elementary school, they calculated your mental age when they did that. That's all of that testing. It was then taken, the information was collected and collated, and they calculated your mental age from that. They usually don't tell kids what their mental age is because it tends to cause problems. All right. How would I do part B?
There was no reason for it to be an
M over 15 times 100 equals 140. Up above, I said you didn't need to define IQ because the problem defined IQ for us. Here, would you need to define your variable? Yeah, you got to tell me what M means here. What is M? M is equal to mental age. I am going to be a stickler about defining your variables on story problems. Tell me what they mean. All right, so looking at M over 15 times 100, I know I'm going to have to do this on the test without a calculator. If I had a calculator, it's a piece of cake. If I have to do this either in the margin of my paper or by hand, first thing I'm going to do is divide both sides by 100, because that's something I can do in my head. Divide both sides by 100, and I end up with M over 15 is equal to 1.4. Times both sides by 15. And now, while I might need to scratch this off in the margin, I only have one multiplication problem to do here. I'm going to give you guys a minute to do that one, and then I'm going to ask you for the answer.
It's 21.
It is 21.
Oh, right.
So how do I write my answer then? Yes. The mental age is 21. Let's do one more and then we'll call it a day. Let's look at one last problem and then we'll call it a day. The cost of installing insulation in a particular 2-bedroom home is $2,400. Present monthly heating costs average $200, but the insulation is expected to reduce the heating by 10%. How many months will it take to recover the cost of the insulation? What are they trying to figure out? Just like before we even get into writing down variables or any numbers, what are they trying to determine?
How many months it will take to recover the cost of the installation?
What does it mean to recover the cost?
Basically get back to what you did.
Yeah, they're trying to figure out when this upgrade to their home is going to pay for itself. They have to put some money up front. Every month they're going to pay a bill for their heating that's a little bit less than the month before. And eventually that savings will accumulate over time, right? At some point, they're going to hit this break even where it has paid for itself. And then after that, they just get to continue to save that money. What should our variable mean here?
Time.
Time. Specifically what?
Months.
Yes. X is going to be the number of months to recover this cost. Yes, you can. If you have number of months, that is sufficient as defining a variable. I know what you have it meaning there.
We just put months.
That would be fine. I'm assuming that you'll get a number answer in the end, so yeah. What I don't want to see is just you have an X show up in your equation and you never tell me what it means anywhere.
I mean, X marks the spot.
It does. That makes us pirates. Where do I go from here?
I don't know.
What do you know about the situation other than X is going to mean months? It's going to have to equal to $2,400. So $2,400 equals X.
No.
I need the amount that they're saving
Yeah.
to be equal to $2,400. 10% of 200. Okay, so 10% of 200, that's the amount they're saving. This is the amount of savings each what? Each month. So I'm going to take that and multiply it by what? X. So 10% of 200, so 0.10 times 200 X equals 2,400. What is 10% of 200? 20. 2,400 equals 20X. I can divide both sides by 20. And I get that X is what? Close. Not 14. Nope. 120.
I was getting there.
Looking at my fraction, my zeros are going to cancel, right? That's dividing them both by 10. I reduce it by 10. Then I'm doing 240 divided by 2, which I can do in my head. So what's my answer then? Yes. In 120 months, how long is 120 months? For 10 years to recover the cost.
It's not worth it.
That depends. If they just bought the house and it's their forever home, it might be worth it.
Maybe it's not.
Maybe it's not. Maybe they don't care about when it pays off for them, but maybe it makes the resale price of the house go up. All right. We'll do 5 through 9 tomorrow. 2-2 homework is going to be due on Monday. 2-1 homework is due tonight. 2-2 is due on Monday.